Now you will have problems like rolling a die, picking a card. Let me see if I can get you some of the other types of examples. All right, now here you might be flipping a coin, but notice that you're flipping a coin 2 times. So in the set, they have already listed all the possible outcomes for you. So you could get a head the first time and then a head the second time. Or you could get heads the first time and then tails the second time. Or tails the first time, heads the second time, or tails on both tosses. So they've listed out that sample space for you. So it wants to know what's the probability of getting a head on the first toss. Okay, probability of getting heads on first toss. Well, that means we're looking for the number of ways to get heads on the first toss over the number of possible outcomes. Okay, so I heard 2. So looking at our list, the only ways that you get heads on the first toss is the first 2 that are listed. Okay, the other 2 does not get heads on the first toss. So we have a numerator of 2, and the total possible ways that this can happen is 4. So 2 over 4, but then again, don't forget to reduce your fractions. So 2 over 4 reduces to 1/2. Notice it's very specific, type an integer or a simplified fraction. Good job. Okay, you might have a chart. Okay, so what they've done for you is they've shown that you're going to roll a die twice. So you're going to roll it once, see what answer you get, then you're going to roll it again, see what your second answer is. So they've shown you a chart of all the things that can happen. You could get a 1 both times, you could get a 1 the first time and a 2 the second time, or a 1 the first time and a 3 the second time, or you could get the 2 the first time and the 1 the second time, and so on. Okay, so they've told you there are 36 equally likely outcomes. You should be able to figure that out with the fundamental counting principle, though. Because how many choices do you have for the first toss? 6. How many choices do you have for the second toss? 6. Fundamental counting principle tells you multiply those together. 6 times 6 is 36 possible outcomes. So I just want you to see how all those sections sort of tie together there. It says find the probability of getting 2 numbers whose sum is 8. Okay, which combinations give you a sum of 8? 2 and 6, 3 and 5, 4 and 4, 5 and 3, and 6 and 2. Okay, so 2 and 6, 3 and 5, 4 and 4, 5 and 3, and 6 and 2. Nice little pattern that you might notice here when you're looking for a sum of 2 numbers. All right, so how many times does this happen? 5 out of how many total possible outcomes? 36. Does this reduce? No, so you put in your answer as 5 over 36. Okay, I wish I'd been able to do some more examples for you, but remember that you have your tutorial buttons there. And there will be some charts where they don't total it for you. You have to figure out the totals.